yesterday, okay? I need to see how far we got yesterday on these notes. We had solved our compound inequality. Yeah, which is at the very bottom of my page. It's at the bottom of your page too. Okay, this today is Happy Pi Day Eve, everyone. Woo! Tomorrow is, bless you, Ross's birthday, and we will celebrate maybe with a song. I should this from scratch, okay? Like we've just seen the problem for the first time. Let's see what we're going to do, okay? So, and again, on your notes, it would be better if you did this in some different color because you know your pencil's going to blend in with the copy. The first thing we have to look at always is, does this thing reflect? Yes or no, does it reflect? No, so sine curve's going to look like that, correct? Then, what's next? Amplitude. Know that amplitude is the coefficient of sine, which is the absolute value of 1, which means it's one above and one below the oscillation line. Then, the coefficient of x gives us portion of the period, 2 pi over who? Which is 2 pi. And now something new we have to do. What is it? We got to find the interval. We're going to indent for the interval. Isn't that neat? Isn't that clever? Interval. How do I find the interval? Times what by 1/4? Wonder if that's why we put it under the period. Yes. 1/4 of 2 pi. And then we figured this yesterday. 2 pi over 4 is actually just pi over 2, correct? That provides us with our interval. Then, what's next? We look at this right here, plus pi over 2, which is going to help us find our what? Phase shift, which is our horizontal shift of our curve. If it's plus pi over 2, we're thinking that it ought to go which way? But it actually is going to go left. It goes the opposite way from what we think. And then last, but it's not there, is your vertical shift. Is there a vertical shift? No, which means our oscillation line is at the x-axis. Now, there's a whole lot of pre-work to this, whole lot of prep work before we can put this graph on paper. Next, we follow the instructions step by step. We set up our compound inequality. What number do we always start with? 0, which is less than or equal to our quantity. X plus pi over 2 less than or equal to what? Is it always going to be 2 pi? No, it's always going to be whatever we have solved for that period. Now, I want you to think about this. What are we doing this for? What we are doing is we are creating a compound inequality that is going to give us a range of values. What it's going to give us, it results in our beginning point to our ending point of our curve. Well, no, because it's not always going to be. This is moving this curve sideways, so we have to do this compound inequality in order to find how many units have I moved it to the left, how many units have I moved it to the right. Yes, ma'am. For the interval is always 1/4 times that period that you have just found. Now, I want you to think of potential mistakes. If I have solved my period and I get it wrong, then what's going to happen to your compound inequality? It's going to be wrong. So your set and your interval is going to be wrong too. So you got to be very meticulous, folks. This is not, again, look what I did. I graded those things. If I give you 2 problems, I can get that stuff graded. Aren't you proud? I was so glad. I was like, yes, got those papers graded. But you have to be very meticulous about this. Now, compound inequality, this is algebra 2. How are you going to solve this? How do I solve and get x by itself? Subtract pi over 2. And this is where we kind of left off yesterday. What I do to one thing, I have to do to everything. Okay? And that's going to give us negative pi over 2 less than or equal to x less than or equal to, folks, what's 2 minus a half? It's 1 1/2, which when we math frac it, it becomes 3 pi over 2. What we have just solved for is, and this is where you want to pick up, our beginning point and our ending point of our curve. Okay? So we have a starting point and we have a finishing point right there. Now, this is when we do, I think we're on step 4. Step 4, right above in your notes. Now, and I would do this every time, folks. Beginning point plus interval equals next. This is all prep work. It's only going to help you. And we do the same thing over and over and over again. Yeah, why not? Okay? Your beginning point is negative pi over 2 plus. Your interval just happens to be, for this problem, what? Pi over 2. It just happens to be pi over 2. And we found that up here. Okay? What's negative pi over 2 plus pi over 2? 0. Now check this out. All eyes up here. Watch. 0 is the next beginning point. What do we have to add to it? Pi over 2. The interval is pi over 2, so we add pi over 2 again. What is 0 plus pi over 2? Pi over 2. Watch this. What am I going to do with pi over 2? I got you. What are we going to do with pi over 2? You're going to put it next, and we've got pi over 2. So we got pi over 2 plus the interval, which is pi over 2. And then what's 1/2 plus 1/2? 1 whole, which becomes 1 pi, or just plain old pi. And watch what's getting ready to happen. Take pi, it's your next value. Add that same interval again, and then folks, what's 1 plus 1/2? 3 pi over 2. Oh, look. How do I know when to stop? When I get to my ending point. Look, I'm there. I'm at the ending point. I have my beginning point. I have my second point, or my quarter point on my intervals. I have my third point, which is my halfway point on my intervals. I have my fourth point, which is my 3/4 point on my intervals. Do I have 5 critical points to go on my x-axis? Yes. Holy moly. Now I'm ready to graph it. All of that to prepare my graph. Okay? Do you have questions so far? I know I'm taking this at a snail's pace, but folks, if I don't, I get lost. I know what to do, but this is kind of difficult to put together. You guys look like you're doing well, though, on these graphs. Here we go. Let's draw it. Was this graph going to shift to the left? Pi over 2 units. And look what your beginning point is. Your beginning point is negative pi over 2, which is going to be over here. Now I want you to listen to me very carefully. You've got to equally space these intervals because they are pi over 2 units away from each other, okay? So I got my first one. What's my second one? 0. You need to mark it. Just because it's the origin, you still need to mark it. It's a critical point. Equally space the next one, pi over 2. Equally space pi. Equally space 3 pi over 2. All right, that's a 3. They're equally spaced. Now, go back up into your problem. We've got to mark our oscillation line, which is where? It's the x-axis. I'm going to mark it because I just have to. What else do I need to mark on my axes? The amplitude. Amplitude for this one is just 1, so that means it's 1 above and 1 below the oscillation line. Do you guys agree? Okay, now I want you to look at it. This is where you go, oh crap, which curve? It's sine. And is it reflected? No, it's the normal curve. Where does the sine curve start? Is it on the axis, on the oscillation line? Yes. Folks, this is where you can... It starts on the oscillation line. It ends on the oscillation line. Okay? At my beginning point and my ending point. And we have lots of checks and balances. Where is this sine curve going to cross our oscillation line? At pi over 2. So it's going to cross right here, which means the maximum value of this curve is going to be where? At 0. So that means my maximum curve is here, maximum value. My minimum value is going to be where? At pi, which happens to be my 1, 2, 3, 4th point. Now, I will be a fart face about if you dip below your minimum value or if you go above your maximum value. Even a little squish, just a little nudge, just a little something, something. I'm going to be a fart face about it, okay? Now, smoothly and beautifully, conscientiously, be sure you take your time when you are drawing this curve, okay? Here we go. I'm going to go up. I'm going to go through pi over 2. There's my minimum. And back to 3 pi over 2. Holy moly. What's it going to do when we move, bless you, the oscillation line? Oh, fun times, fun times. And then just for kicks, because what I'm understanding from students who are coming back from 4-year universities is that you don't really have your head wrapped around domain and range. So just for kicks. What's the domain of this curve that we've just plotted? Domain has to do with the width or the height of the curve. The width. So domain is from what to what? There we go. Negative pi over 2 to 3 pi over 2. Let me ask you something. Is this going to get parentheses or brackets? Why is it going to get brackets? Or if it's not included. Is this point included on my graph? How do I know? It's the beginning and it's a closed circle, right? So it's going to be brackets. How about the range, folks? This one's easy. All right, let's go from smaller number to bigger number. -1 to +1. I always like to go in chronological order. And is it parentheses or brackets? Brackets. And just for kicks, what would this be? I'm just saying, folks, you better be thinking about how I can ask questions on your next test. Give me the ordered pair for the ending point of this curve. Look, don't look at it. Listen to what I'm asking. Give me the ordered pair for the ending point of this curve. When you think you have it, raise your hand. I need the ordered pair for the ending point of this curve. Beth, what do you think it is? 3 pi over 2, 0. How many of you agree like, oh yeah, now I see it. When we plot points, don't we go left and right first and then up or down next? What would the, what's the maximum values ordered pair in this curve? Who's got it? Let me say that again. I need the maximum values ordered pair for this curve. Luke Hayes. The maximum value. Oh, no, I did not. How many of you see, how could I have done that? You see it, and you're like, I got this. That makes sense. Do you see what kind of minor little questions I can ask about this? Will I do that? Oh, yeah. Absolutely. Yes, ma'am.
How do you get the...
Oh, we love cosine. Yes, we do. We love cosine. How about you? Yeah, we love cosine. All right, we go through the same process, right? Isn't it wonderful to be this happy all the time? This is called sleep deprivation, y'all. Woo! Here we go. It's that would be awful. Okay. If I taught class like that. Ooh, boring. Right, Morgan? Did you hear anything I just said? Oh, okay. Don't say names. Okay, good girl. All right, what's the reflection? Is there a reflection? Nope. Cosine. So if there's no reflection, this cosine curve is going to be the up cup, the down cup. Up cup. Draw it. What's next? Amplitude. Shabba-la-la-la. Amplitude. Absolute value of 1. Which means my curve's going to start 1 unit above or possibly 1 below the oscillation line. What's next? Period. Which is always 2 pi divided by 1 in this case, which is 2 pi. And now we indent for the, look how clever, interval, which is 1/4 times 2 pi. Heck far, look at there. It happens again, right? Pi over 2. Again. Do you guys agree with that? Yeah? What's next? Phase shift. Okay, here we go. Please don't misspell this. Phase shift. Which way is this curve going to move? To the left, to the left. How many units? Pi over 2 units. And then vertical shift. Don't misspell that. Because it's so easy to misspell vertical. It is. It is. What is vertical shift? Is there a vertical shift? I'm sorry, this is so stupid. There is none, which means my oscillation line is where? X-axis. There we go. On X-axis. Oh, okay, mercy. Here we go. What's next? We got to do what? Nope. What do? The sign language 4, inequality. Here we go. Where does it start, Easter? 0. Less than or equal to who? Parentheses, x plus pi over 2. Less than or equal to who? In our problem, the period is 2 pi. Hallelujah. That's always the compound inequality. Always, when we write this, it always has 0 here. The parentheses, whatever's in your parentheses goes here. You with me?
Yeah.
And then my last value is the period that you just found.
So, okay, 100 period.
Okay?
And then the first one is always
0. Okay, here we go. Let's solve this algebraically. Subtract pi over 2. Subtract pi over 2. Negative pi over 2 less than or equal to x less than or equal to. Thank you. That means answer me in sign language. And We are at the compound inequality. Ooh, what do I write now? What do I have to write now? Every time. Beginning plus interval equals next, right on? What's my beginning point? This is always the period that you just found. And in our problem, it just happened to be 2 pi, bless you. Okay, that could change, and it will change tomorrow. Okay, here we go. Beginning is negative pi over 2 plus, what was our interval this time? Pi over 2 again. Hello. Negative pi over 2 plus pi over 2 is 0. Put 0 down here. What's 0 plus pi over 2? Pi over 2. Pi over 2 plus pi over 2 is pi. Pi plus pi over 2 is 3 pi over 2. Am I done? How do I know? Because I reached. Is that right? That's correct grammar, isn't it? Reached. Bless you. That is correct grammar, isn't it? Reached. Sounds weird. I reached the last point. Right on? Holy moly, am I ready to graph this thing? Yep, here we go. Pi plus pi over 2, because it's 1 plus 1/2. 2 halves. Did you just answer your own question? In your brain. Okay, all right, but you got it? All right, here we go. Hey, this little thing right here, I think y'all's is on the next page, maybe. Maybe not. But let's graph it. Let's graph it. Let's graph this thing. Nope, we're doing the problem. I don't have room. I'm going to create another slide. I have that option. Y'all don't have that option. You don't have that button on your desk. Why are you confused? Because I'm not doing anything yet. Okay, don't be confused. Okay, because I don't have room. You don't have to, okay? All right, here we go. I need to check this out because my oscillation line is on the x-axis. Boom. So I'm going to create my oscillation line. There it is. Then, is this shifting to the left? Yes, it is. All right, so let's put our values in there. Negative pi over 2. Please don't forget to mark 0. I'm going to be very angry if you don't. And write ugly notes on your paper. Equally, piece those pieces out there. All right. What else do I have to do to my graph? I got to label my y-axis, which in this case is what? It's 1 again. Hallelujah. There's 1. There's 1. Hey, which curve is this? Because this also could be a potential problem. What if somebody did that on their paper yesterday? I don't remember which class, but somebody, it was supposed to have been a cosine curve, they graphed a sine. On sine curve, they did the other one, or vice versa, or whatever. But I was like, oh, which one? Cosine, so it's my cup. Where does my curve start? At negative pi over 2, 1. Do you guys agree with that? Where's my ending point? Is it going to be up high, down low? It's up high, down here above my ending point. Where's my minimum value? It's going to be under pi over 2, isn't it? And then where is my curve going to cross the oscillation line? At which critical points? At 0 and pi, or my second and my fourth one, right? So here we go. Smooth and beautiful. Smooth and beautiful. Boom. Look how pretty. What do you think about that? How many of you had it 5 minutes ago? High five. There we go. So, all right, so help me get through this quickly. Is this going to reflect? No. It's cosine, so it's an up cup, correct? All right, amplitude, absolute value of who? 1, thank you. That means 1 above, 1 below the oscillation line, period. 2 pi over, which is 2 pi. Interval, which is 1/4 of 2 pi again with the pi over 2, holy whatever. Here we go. Then phase shift. This one's going to move which way? Right, pi over 4 units. Is there a vertical shift? No, and it's at the what? X-axis. Y'all cool with that? How many of you had all of that? Rock on. Is this one going to be on the left side of our graph? No, not at all. We're not there yet, but just thinking. Compound inequality, what's it going to be? 0 less than or equal to? Yep, less than or equal to 2 pi. This one's going to be different. We got pi over 4 less than or equal to x less than or equal to, what's 2 plus 1/4? It's 2 1/4, which is 9 pi over 4. Do you guys agree with that? Round and round. Yes. Yes, ma'am. Shh. Because phase shift is this piece right here. It's going to be opposite, bless you, right this amount right there. Okay? So it's going to be right pi over 4 units. Okay? All right, so now let's see what's going to happen. Beginning point plus interval equals our next point. Here we go. Pi over 4 plus, what's our interval? Pi over 2. Folks, this is all about a calculator. I don't want you to get caught up in all of the fractions. Throw this in your calculator. What's 1/4 plus 1/2? That's 3/4, or 3 pi over 4. Next place. What's 3/4 plus 1/2? 5/4. Again, math bracket. Look at the pattern that is occurring. I add it to the interval every single time. Oh, I guess the next one's going to be what? 9/4, right? 3, 5, 7, 9. Now, if you recognize the pattern, somebody said, do I still have to do all that work? All you need to do is this right here. Just write pattern and I got you. I understand. Okay? Now I've got, go ahead. Okay? Now, let's graph. It's going to be heavy on the right side because there are no negative values. My first beginning point is pi over 4. Equally space these, 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4. Okay? And then this is the cosine curve again. What else do I have to do to my axes? Amplitude, which is 1 again. I also need to mark my oscillation line, which is the x-axis. Cosine curve, which is the up cup. How many of you had it start here, end here, minimum value here? It crossed through the second value and the fourth and back up. How many of you had that correct? High five, y'all. Very, very good. Question? Two, 0. Yes, that's why I keep, hey, listen please. That's why I continue saying when we do amplitude, Have y'all noticed I always say one above, one below the oscillation line? If I don't continue saying that, I'm going to forget, you're going to forget, all God's children are going to forget. Okay? I don't want that to happen. I do not want that to happen. Here's what you are going to do for me for homework. Oh, yeah. And this can be a working Pi Day Eve. Yes. On page, because you got plenty of time. Holy moly. You got plenty of time. Well, we're going to partay with trig and pi. I will play music. Now, let me tell you something. 35 and 36, folks, when you look at that, I want you to bow up, and I want you to give those two problems a shot. Because I'm giving you the graph, and you've got to figure out the equation. I'm going to make these people back here go first. I know. Don't be. Do you look at 35 and 36, folks? You're going to have to start with the graph and work your way backwards for it. You should be more frightened of the. I'm sorry. I didn't mean to make you pee a little. Stop. I'm sorry. All right, look. Woo! All right, listen. Don't write notes. Here's what you. I got you. 35 and 36. Seriously, think about it. Work with each other on those. Don't come back there and go, I don't know what to do. Don't do that. That's so not cool. When you do that, Quentin, that's so not cool. Not even when anybody does it.